How's it going, guys? It's Jiggy here, and in this video we're going to be taking a look at something called partial functional application, which follows on from what we talked about in the functional application video. So let's get straight to it. We'll be taking a look at what partial functional application is, and then we'll take a look at more formal notation that you're going to need for your exam. In our previous video, we talked about function evaluation and how a function with 3 arguments is broken down into a series of functions, all of which have one parameter. What happens if we want some control over this breakdown so that we can define these functions ourselves? Well, that's where partial functional application comes into play. Partial functional application will allow you to pass through less arguments than what the function actually requires. So let's take a look. Suppose we had a function called add two numbers with x and y as its parameters. Of course, that's going to take in 2 arguments and add them together. If we partially apply the functions, it means that we're going to be trying to pass less arguments than it wants. So if we just try to pass in one number, such as 5, there's going to be a problem since we only have one integer parameter. So right now, add 2 numbers with an argument of 5 will be described as partially applied since we haven't passed in all the arguments for it yet. One key thing to note is that in order for partially applied functions to get their missing parameter, they are passed in as arguments to other functions. So let's go ahead and understand this. What we'll do is we'll use this partially applied function as an argument for another function like we just talked about. You'll see how this is going to help add 2 numbers when there's only one parameter passed to it, get its missing second argument. Suppose we had a function which was called add8. And of course, it's just going to add 8 to whatever's supplied to it. It's going to take in the add 2 numbers function, which only has one argument passed to it. That will mean the definition of our add 8 function will be like this. It will accept the add 2 numbers function as input like we just showed, and it's going to affix 8 as the second parameter for the add 2 numbers function. Now you can see that the add 2 numbers has its second parameter. If we called add 8 with argument 5, it's going to result to add 2 numbers with arguments 5 and 8, which of course is going to result in 13. So you can see that the partially applied function with add 2 numbers with argument 5 is going to be used as a parameter for another function in this sort of way. We're going to need to mathematically formalize this concept for A-level, and it's going to look something like this. We read this as integer maps to another integer, which maps to another integer. You can see how this works in our example, since add 8 maps to add 2 numbers 5 in order to produce an integer result. So that's it, a pretty short but potentially tricky topic. Let's have a recap. Okay, so we say a partially applied function is one which does not have the required amount of arguments. Normally, this would be an issue, but in fact, we can use them as an argument for another function. And finally, this is how we mathematically formalize it.